All right, so let me hide these and we'll get going. So hopefully Canvas will allow me to update or upload this file here. I was going to do it from up here. I guess I should have done it from my office, but I'll eventually get it up there on Canvas, even if I'm not able to. We'll start working through it today. So you won't be able to work along with me. But you could have kind of Excel opened up and just kind of follow along, trying some of the things that I'll show you. Like I said, hopefully I'll be able to upload this here as we kind of progress through today's class a little bit. I'm not sure why it's kind of showing me the assignments and things, but looks like the files tab, well, everything's kind of going a little bit slow. So we'll kind of pick up where we left off, which was, I believe, I showed you how to do time series graphs. Did I show you guys how to do scatter plots? Did we get that far? No, I thought that's where we left off. Okay. So I can't see the files yet, but the one that should be up there was that graphing data week 1 in class. That should be on Canvas. That was the one that we were kind of working with. In class, this is saved to what we did last class. So we've got this kind of scatter plot data worksheet. Up to this point, we've really kind of looked at how do we visualize like one variable, right? But sometimes we might be interested in the relationship between two variables. So I think, the examples that I have, scatter plots. Here we go. Skip around a little bit. So I'm thinking about scatter plots. I might be interested in the relationship between two variables. So call one of these variables X, the other one Y. And this is like years of education and income. So for every single observation, I'm going to have a recorded income and a recorded years of education, right? I've got an X and a Y variable. I can just use those values to plot every single observation somewhere on my graph, right? So 13 years of education on the X-axis, and then go up to maybe they make $30,000, right? Plot that point. So if I had a different data set, and it looks like healthcare expenditures per capita and life expectancy, maybe I'm interested in the relationship between these two variables. I'm just going to go ahead and plot these, right? So I'm going to use, I think, healthcare expenditures goes on the X-axis, life expectancy on the Y-axis. So for the very first country, go over to 3,452 on the X-axis, then go up to 81.5, draw a dot that represents Australia. Do that for every single country, and we end up with something that looks a little bit like this. Right? So, this is a nice quick visualization that, if I'm trying to draw a line that best fits this data, it probably is kind of like a slight increasing line. You can maybe argue that, I don't know, it's maybe kind of everything comes around, maybe the line's kind of flat. So maybe there's a positive relationship here, but not very strong, right? If I was trying to draw a line that best fits that data. We'll go kind of more into this with people in your regression, thinking about how do we actually come up with what that line of best fit would be, right? So, I've got a couple of the countries here. Yeah, United States. Oh, come on. There we go. So you can kind of see here, even the state that's spending the most, or the country, the United States, right, has the second lowest life expectancy out of all these countries, right? So, that might be somewhat of a leading indicator that maybe spending more money on healthcare isn't necessarily reflective that they're going to be healthier people, but maybe they're spending more money because they aren't healthy, right? And so maybe that's why we kind of see the United States be down there. So it's kind of an interesting, look at the relationship between two variables. I had another kind of data set at one point. I looked at the percent of the states that percent of people who are vaccinated in every state, as well as the number of new cases. I think this was from last fall. This is where I grabbed the data. So 2021, and I don't know, if I try to draw a line that's just this data, like maybe it's slightly decreasing, right? If I can get a higher percentage of my state vaccinated, that maybe I can see a smaller number of new cases. Although we do have some kind of weird outliers going on here. I forget exactly what states those are. But how do we create these scatter plots? All right. So if we go to that graphing data and we go to that scatter plot data worksheet, I had every single state's as up to date as I can get. Their last year's violent crime rate, as well as whether this kind of measure of what percent of their students were not reading proficiently. And I forget exactly how this was measured, but we'll kind of notice a lot of states aren't doing very good. So one thing I want to show you in Excel before we kind of graph these scatter plots is, remember, if I go to this very first cell hold Control Shift or Command Shift on a Mac, use my over and down arrow, right? It'll select the entire data set for me. So once again, I just went to the very first observation, kind of where that variable title was, Control Shift, Command Shift on the Mac, hold those, hit the over, and then hit the down arrow. So once I've selected the entire thing, I'll go up to this data tab and make sure that I've got this filter tool on. So I turn it off, right? This is what it would look like. And I try to upload these with the filter on. Most of the data that if I sent you data, other than one person who sent me an email this morning, maybe two people sent me an email this morning, I've responded to everyone and kind of got you some data back. I tried to remember to throw the filter on there. If I forgot, select your entire data set, go to the data tab, click filter, you'll see these little arrows pop up for each variable. It's just a helpful tool. So you'll notice very quickly, first of all, it shows me all the different values that have been recorded for that variable, but I can sort it so that I can see, okay, what state had the lowest percent of students not reading efficiently. So that's actually a good thing, right? That means that if I have a low percent of students who aren't reading proficiently, they're going to have a higher percent of students who are, right? So kind of our typical, I guess this is what I would expect, right? The first four are these like northeastern, higher income, pretty low poverty areas. Well, lo and behold, their students are doing the best. Whereas if we scroll down here, New Mexico, Mississippi, Louisiana, DC, those are going to be kind of our states that have the most students that aren't reading proficient. So that filter option just kind of makes it nice. I could go over here, who has the most, violent state, I guess, and I sorted that from largest to smallest. Oh, DC is not a good place to be, right? Well, a lot of violent crimes there per capita. And then you can kind of see, as we worked on this, thinking Alaska is probably because there's like nobody up there. So one violent crime increases the rate a whole bunch, but you kind of play around with this. It's kind of interesting. So that filter tool is something that's useful. We'll kind of use that moving forward. But I just want to graph this, right? I want to create a scatter plot. So I'm going to hold Shift and hit the arrow, right? So if I just hold Shift, it moves over one at a time, right? So for instance, if I hold Shift, hit the over arrows, I can select one column at a time. It was when I hold Control Shift or Command Shift that it selects everything right at once, right? Well, I only want to select these two variables. So I'm going to hold Shift, hit the over arrow. Then while still holding Shift, I'm going to also hold Control or hold Command on a Mac and hit the down arrow. So I've selected the entire columns of both of these variables. Any questions on that? Okay. I'm then going to go to Insert. And it's just like the graphs we were doing last class. It's pretty easy. I just have to find the one I want. Well, here's this scatter plot. That's what I wanted. I'll insert that. And I can play around with things. So notice there's like this plus sign here. I can add axis label or axis titles, data labels, so I can see what the actual values are. There's some fancier things you can do where you actually go in and select the state names so that you can put the state names on all these. I'm not going to kind of ever push you that far. I just want you to be able to kind of take the data and put it into a scatter plot, right? Because we don't really care necessarily which states the dots represent. What we care about is what's the relationship between these two variables. And so I'm going to think about it here. I've got violent crime rates on my x-axis, and I've got those percent of students not reading proficiently on my y-axis. Well, notice as the percent, you could think about this either way. I'm not really sure which one is causing the other, right? As the percent of students who aren't proficiently reading goes up, looks like crime rates tend to be going up a little bit as well. Or said differently, as crime rates go up, we see the percent of students not reading proficiently also goes up. So I'm not sure which way the causal effect goes there. This is just evidence of a correlation, right? Maybe it's that the crime rate in the area is causing kids not to be able to focus on their schooling and then subsequently not being able to read proficiently. Perhaps students not reading proficiently is reflective of their home life, which is then leading to crime. We can't really say just given this data, right? We have to kind of gather more variables and do something called regression, which we'll get to later this semester. But this is a quick first look, right? There's something going on, right? These two things are somehow tied to each other, right? Any questions over that? Shouldn't be too bad. Instantaneous scatter plots, pretty easy. Let's check on Canvas here. Okay, my files is still not opening up, so I might have to contact someone later today. we'll go back here. So we talked about time series data. Pretty sure I showed you that last class, right? Kind of with the unemployment rate, that was just inserting a line graph. The next thing that I would want to do is think about, all right, we looked at the causes of death last class, and we said we could kind of create these bar graphs that showed the frequency distribution for these qualitative variables, right? Because the cause of death is non-numeric, it's a qualitative variable. Well, what if we wanted to do quantitative? Well, if it's discrete, it's really just like what we were doing before. So instead of the cause of death, right, maybe it's something like what percent of, or what's the frequency for the number of households that have 0 kids? And what's the frequency for households that have 1 kid, 2 kids, so on and so forth? Well, then I just look at the data set, count up the number of households that have 0 kids, write that frequency down, go through the data set again, count the number of households with 1 kid, write that number down, do that for every single possible number of kids up to, you know, I don't know, whatever that goofy family that has like a, I don't know, whatever station puts that garbage out. But right, I would have all these frequencies, I just highlight them, insert a vertical bar graph, just like we were doing with the qualitative data, right? So it's the same process. It's just I'm counting the number of times I see a 1 instead of the number of times I see the word heart disease. However, when it comes to continuous data, we've got a problem, right? Let's think about income. Let's say I wanted to create a frequency distribution for income. So I go through my data set where I've got people's incomes recorded, and I have to count the very first value I can see is how many people make $0, right? Write that frequency down. How many people make 1 cent? Write that number down. How many people make 2 cents? Write that, right? If I do it that way, I'm going to have the most ridiculously long, long vertical bar graph. It doesn't make any sense. I can't really show a good visualization of that. So what I'm going to have to do is create these bins or classes where I count the number of observations in those bins or classes. So maybe I do something like how many people make between 0 and $50,000. I count those up, write that frequency down. Then how many people make between $50,000 and $100,000? Count them up, write that frequency down. I then continue to do that all the way up to, whatever the highest income in my data set is. And now I've got a small number of bins or classes that I have the frequencies for. And then I can just graph those into a bar graph, just like what we were doing with our frequencies for the qualitative variables. Right? So the only really added step is we have to create these bins or classes. So how do I do that? Right? I just made that one up, 0 to 50,000. Why did I do that? Well, generally, to create these histograms, what we'll try to do is keep the number of bins or classes relatively small, but also not too small to not be interesting, right? So fancy word for these bar graphs, when we forced the data into these bins, or I have counted the frequencies in these bins, is histogram, just a fancy name. It's a bar graph for continuous data, right? We're forcing kind of them in these bins. So if we only had 2 bins, and that bins and classes, those 2 words are interchangeable. I'll almost always just refer to them as bins from here on out. But if I only chose 2 bins, and I did something like how many people make between 0 and $100,000 and how many people make more than 100,000. Well, that's not a very interesting graph, right? So I want to create quite a few bins, at least 5 usually. But if I go more than 20, I just back to the original problem. I get this really long vertical bar graph, and it doesn't look as nice. It doesn't display information as interesting. Now we can increase that. It kind of depends on the example, but in any homework problem, you'll be told what that bin is, what that number of bins would be. Okay. And as we work through an Excel example, at least started today, you'll kind of see, I'll give you some starting number of bins. So once we do that, we kind of our starting point, or maybe think about it as the formula that's going to give you the optimal bin length, right? Is you take the highest value you see in your data set, subtract the smallest value you see. So this would be like taking Jeff Bezos minus 0, right? The lowest value you could see is 0. Whatever that range is, then divide it by the number of bins that you want to use. And this equation would give you kind of what that bin length should be. Now, when I say bin length, in my example where I said how many people make between 0 and 50,000, well, the bin length there is 50,000, right? Because then the next bin is 50 to 100,000, then 100 to 150,000. Okay? So this equation is going to tell us what that optimal bin length should be. Maybe it's 50,000, maybe it's not, right? Maybe it's something else. Right? Now, once we start actually working with an example, you'll see like this is just usually a starting point to give you a rough idea of where you should start out at. And I'll show you why here with an example in just a second, why this is just your starting point, and then you kind of have to just use your brain a little, right? So we want to make sure that whatever the bins we've created are, that they meet the following, right? We want the bins to be mutually exclusive. So this means that there's no overlap. So we have to be really careful. One thing, to make sure this is met. So in my example, I was being pretty lazy, right? With the way I was talking about it, saying how many people make between 0 and 50,000 and how many people make between 50 and 100,000. What's the problem with that? If I had somebody who made exactly 50,000, well, the way I said that, they'd be counted in both bins. We only want every observation to be counted one time. These bins should be mutually exclusive. There's no overlap in the bins. That's all mutually exclusive means. Okay. So it just means I have to be really careful that I say how many people make between 0 up to and including $50,000. That's my first bin. But then the second bin would then have to be how many people make greater than 50,000. So I just have to be careful with my equalities there, right? That's the only way we really get tripped up. It has to be exhaustive. Every bin, right? Sorry, every observation should be counted at least in one bin. So the only time we run into problems here is if you don't use this formula, right? Because you might do something like do these $50,000 bins, like 0 to 50,000, 50 to 100, and then maybe you stop at like $1 million. Well, there's some crazy uber rich people making, more than $1 million a year. You're not going to count them. So your bins would not be exhaustive. So a lot of times to deal with this, we'll do something like the $50,000 bins. And then once you get to, I don't know, 250,000, you just say, create a catch-all category, kind of like we did for the cause of death. We had the other. I would just say, count the number of people who make more than $250,000, right? And then I just kind of have that last bin be open-ended. That's a good way to not, make sure I'm counting every single observation. But generally, we want to keep the bins the same length, with the exception of these catch-all categories. Okay. All right. So, kind of a sample question to look at this, right? Let's say I had SAT score data for all the Indiana high schools, at least 356 of them. The highest average SAT score was 648. The lowest school was 352, and I want 9 bins. What should my optimal bin length be? So this is kind of another good example. Like I said, I won't start using iFlippers until Monday for points. This would be another good example of what it looks like, right? We kind of talked through it a little bit, right? So we've got the equation. Probably in practice, I would actually work through one and then ask you that question. Unless you've seen me kind of, now this is a pretty easy formula, right? If I have the maximum value number of bins, it's really just a matter of having that formula in front of me and then plugging in my values, right? 648 minus 352 divided by 9. If I do that, I get about 32.88. Now notice I've only put the integers here. In practice, if I use this formula and I come up with 32.88, why is maybe that's not a number I want to use to create my bins? Huh?
It's harder to do.
Yeah, I mean, what's our ultimate goal? We want to get a nice visualization of the distribution of this data. My labels are going to have like these repeated, 0.88 repeated, and the cutoffs aren't going to be quite as easy to think about. So a lot of the times it's just a starting point. We'll then kind of just use the next integer, or in certain situations, it might, like income, it might make sense to use the next 1,000 or something.
So the bin is the amount of categories, and the length is how big those categories are.
Yep. So the bins. So before, like when we had the causes of death, the bins will essentially be how many causes of death we had, right? And then the bin length is just the range of each one. So where does it start? Where does it stop? So in this example, right, all of our bins are going to be 33 units wide, or 33 SAT points wide here. Our units are points. Now, if we use this and then we don't use the exact decimal, we need to always round it up. When I say round it, I actually mean even if it was 32.1, you have to use 33. Because if you don't, and let's say I just drop this down and had 32 as my bin length, what's going to happen? When I get to that last category, it actually won't be as high as that maximum value. So it wouldn't be exhaustive anymore. So if I do round it, I need to round it up. I need to push it up. Sometimes in Excel, the function we use is called ceiling. So I say we need to ceiling it to the next integer, right? Doesn't matter if it's 0.1, if it's rounded up to the next highest integer. So here we would use bin lengths of 33. Right? Any other questions on that? Yeah.
So What are the classes again?
So bins, classes, those two terms are interchangeable,
Okay.
right? So bins, classes, like I said, you look at the book, it uses the terminology classes sometimes. Talk to a guy in the stats department or the girl in the stats department, right? They would probably use the term classes. For a business or more applied setting, we generally kind of call them bins. I don't know why, but that's just, you know, those are two terms interchangeable.
Oh,
Okay. So we can do these in Excel. All right, that's the summary of this slide, right? We can create these in Excel. Let's see, hopefully Canvas is cooperating. I can get this file up there. It doesn't look like it's only the files tab for some reason. I'm gonna cheat and see if this works and create a temporary assignment. And we're going to be smarter than technology sometimes, right? Okay. Don't worry, I'll get rid of this after class and just get the file up under files on Canvas. Hopefully you guys can start to see this now. You can download the file this way. That'll be our way to get around it for today. So sorry about that. Like I said, I should have just done it on my desktop. I figured I could do it before class started, and of course I got it aired. So wish I had a better seat here. Once you open that enrollments blank file, we'll wait for it. We've got two worksheets here. So we've got a bunch of different universities. I have kind of what state they were in and what their total enrollment was, right? I also have this Indiana worksheet, right? So we're going to work with the Indiana data, and you know, I'll post the completed version of this. We'll probably just work on the Indiana stuff in class, but then when I upload it, this will also have well, we might be able to do this in class, but if we're not, this will just be another example you can kind of look at as you're working on that first Excel assignment, which I will likely assign after class on Monday. So we'll kind of get started in this example today. I don't know how far exactly we'll get. I don't think we'll be able to complete it all in the next 30-ish minutes. So we'll finish it on Monday, and then I'll put up that first Excel assignment, which will do some of the basic little graphing stuff that we've done up to histograms, right? Which is taking continuous data, forcing it into these bins. There we go. So let's go to Indiana. I've got it zoomed in. You know, I just have a subset of, you know, the different universities we might find in Indiana. Looks like what, there's about 50 of them. I've got them sorted. So I already had the data filtered. You can kind of see the largest down to the smallest. You know, Ivy Tech counts every Ivy Tech school. So it's kind of interesting to see, like, their enrollment is huge, right? But then we'll go over here, and I'm going to actually, to make this easier for us to see, you don't have to do this for you if it's pulled up in front of you. I'm just going to delete these columns. There's nothing in them, and that's just so I can get the data to be a little bit closer to what we have over here. So I kind of cheated. I already have all these things ready to go. These are just my labels. We'll eventually use these for graphing the histogram, so we will see why these are useful down the road. In practice, you would have to type these out. There's no easy way to do that, unfortunately. On the Excel assignment, I'll actually give you a Word document that already has the labels like in a Word table. You can just copy and paste those, so you don't have to type them all out again. So let's assume we've got this enrollment data and we want to create a frequency distribution and show it visually, right? Have a histogram for all these different universities. Well, we know that we first need to figure out what's the optimal bin length. Well, here I'm telling you, let's only have 6 bins. We're going to keep this kind of small, right? A small number of bins. So you've had to have been told that, right? Now to calculate our bin length, we know we need 2 other things. We need the maximum value in the data. We need the minimum value. Now, if I've filtered this, I can see the maximum and the minimum value here, right? I could go up here, type those numbers in. But what if I then get some more data on some additional universities? I can put those into my data set. Now things might change. I got to go back and type, you know, everywhere where I had that minimum value, I have to, you know, change it. Let's use some built-in functions in Excel, kind of like we did with the cell references, so we don't have to change things, right? So the first one, we put an equal sign to get the minimum value. The built-in function in Excel is just min, right? Pretty easy. I then put a parenthesis, and then it wants me to select the numbers I want to find the minimum of. Well, I'll just go over here, select that very first observation, and then how do I select the entire column? Do we remember? Yeah, hold Command and Shift or Control and Shift if you don't have a Mac. Hit the down arrow, it went all the way to the very last observation, right? I'll scroll back up here just so we can see it. You don't have to scroll back up once you do that. So I'll show that to you again. And notice it had that cell reference in there for me. So I have min function, start my parenthesis, select the first cell, Control Shift or Command Shift on a Mac, hit the down arrow, and now it's put that cell reference in there for me. So this colon here means look through cell C2 all the way through C51 and return to me the minimum value. Now, if instead of scrolling, I just wanted to go back up, if I just hit enter, it'll automatically close that parenthesis for me and then just get me out of that cell. So notice it's identifying the minimum, right? And because we have this sorted, we can kind of verify that. Any questions on that before we keep moving? If to find the minimum, we used equals min and selected the variable, what do you think maybe to find the maximum we can use? Equals max, right? Pretty easy, right? Usually these are functions are named appropriately. So I'll once again select that variable, Control Shift, Command Shift on a Mac, hit the down arrow. Once again, to get out of the cell pretty easy, instead of scrolling up and closing the parenthesis, if I just hit enter, it'll do that for me, and it's found that maximum value. Okay. And when I'm double clicking on this, it shows me the function. I then hit enter to get out of the cell, and then it shows me kind of what that function is going to return. Okay. We're okay up to this point. Shouldn't be too bad. So then how do I find that optimal bin length? Well, we said I'm going to take the maximum value, and here, once again, don't type the numbers in, just select the cells. You've already got them there. It's a lot easier to click on one cell than type out this big number. So I'm just going to take my maximum. I just clicked on that value. I'm going to subtract the minimum value, right? And I have some weird setting that I have to change on my laptop because I then want to divide by the number of bins. It's not allowing me to select that. However, I know that cell, the number of bins was G3. So I could just put divide by G3. Now, what I was going to say, so what's the problem if I do this, right? Well, I have to remember that when I'm using Excel to do math, order of operations still applies, right? So here it would have divided the minimum by the number of bins and then subtract. I don't want to do that, right? I want to divide the entire difference, right? What's in my numerator is this maximum value minus the minimum value. I always say err on the side of caution, just throw in parentheses, even if you're not sure if the order of operations is going to work correct, try to kind of use parentheses to make sure that it's going to do what you want, right? Any questions here? All right. So I've got my optimal bin length. Well, it's not a pretty number, right? But I'll show you if we were to use that, we'll go ahead, build this out, figure out, can we still come up with a frequency distribution, right? So if there's minimum value, right? The way we're going to set this up in Excel, we're eventually going to use this formula called Countifs. Once we get there, it'll make a little more sense why I'm setting this up the way I am. But basically, you want to have two columns where you have the minimum and the maximum value of each bin. So for instance, here, I want 279. Here, I want 12,347.33. And then down here, the minimum of this bin, 12,347.33, maximum 24,415.67. Now, the equalities, right, are only on one of these bins, but I'm still going to use kind of what that cutoff value is, right? So even in this first bin, right, 12,347.32 is actually the highest number. We're still going to use kind of where it stops at, right? Where that equality kind of switches between the two bins. So instead of typing this out, there's probably a way I can do this kind of quick with cell references, right? So instead of typing in 279 here, what could I do? Well, I've got that value up here identified as the minimum. The whole reason why I use the minimum function is in case we added data in, then the minimum will get updated. So I'm just going to use a cell reference and say the first bin starts at whatever the lowest possible value is. Right? Does that make sense? Or any questions why we do that? Okay. Then how do I know the maximum of each bin? Well, if I know the optimal bin length, this first bin starts at 279. It's just going to end at 279 plus whatever the bin length is, right? Because that's how long the bin is. So start at the minimum, go, 12,068.33 above that, and that's where that bin stops. So down here, I'm going to say, take whatever value this bin starts at and just add to it what I know the bin length should be. Yeah.
Does it matter if you G7 or G1?
You could reference G2 here for this first cell, but you'll see there's something I'm going to do that using this G7 will actually be a little more helpful than using G2. Just a second. Okay. So we understand what's going on here. We're just starting where the bin is going to start at, and then adding whatever that optimal bin length is. That gives us where the bin stops. Okay. Well, for this next one, the cutoff values are always going to be the same. This bin just starts where the last one left off, right? It's pretty easy. I just use a cell reference there. And then where does this bin stop? How did I come up with that 24,000 number? Well, I just said, go where the bin starts and add to that the optimal bin length. All right. Okay. And then I would just keep doing this, right? The next bin starts where the last bin left off. Where does this next bin stop? Well, start at 24,000, add the optimal bin length to it, and it should kind of stops at that 36,000 value. Now, one thing is I don't have to type that in. I don't have to keep equal sign, select a cell reference, because now think about it. If I copy this down, what happens to my cell reference? Instead of H7, when I copy this down one, it would become what? I'm going down one row, so it updates the cell reference one row. It would be H8, which is actually exactly what I want to be here, right? I want equals H8 to be here, so this bin starts where the last one left off. So if I copy this down, notice it updates that cell reference, and it's just going to the previous bin, right? So I don't have to keep typing this in. I can just drag that down, right? Same kind of thing here. If I drag this down for the next bin, well, I don't want to start at 12,000 anymore. I want to start at where this bin starts, which is the 24,000 value. Well, G8 would become, if I copy this down one, G9. Oh, okay, that's what I want. But what about G4? That would update to G5. That's a blank value. That's not what I want. So I do want this cell reference to update when I copy it down, but the bin length is always going to be the same. So if it's always going to be the same, I want that cell reference to not change. Remember how we did that? Did I show that to you guys? Don't think maybe I did. I get confused. Till you guys get a little bit further ahead of my other section, I might get a little confused here. So anytime we don't want a cell reference to change, we put dollar signs in front of it, right? So this is, when I copy this down now, G8 will update to G9, right? But G4 will remain as G4, right? So we kind of can see this. I copy this down. Notice that cell reference of G8 updated to G9 because I copied it down one cell. But the one that I froze, where I put the dollar signs in front of the column and row reference, that didn't change. It stayed as G4. Okay. So I showed you guys a little bit of cell reference at the end of last class, right? Just kind of how you can, yeah, but we didn't get to freezing. Okay. Any questions up to this point? We're okay with this? We're having any issues following along? Yeah.
I'm just doing the same number. Like if I go on 36,484. I tried to do the same thing. It's just giving me 36,000.
So if you double click on the cell, what's your formula look like?
G10 plus $1.95.
So you wouldn't want it to be G10, right?
But it's the next one.
So if you copy it down here,
Yeah.
well, if I copy it down here, it's going to be an issue if I didn't copy this column down as well.
I did.
So go up to this one, right? Go to cell H9, right? If you double click on that cell, what does it say?
Oh, you don't have a dollar sign for each?
So you got to have a dollar sign in front of the column and the row reference.
I have.
Yep. So if you do that, when you copied it down, it would have been updating the row, but not the column. So you need to make sure you put dollar signs in front of both, right? So one easy way to do that, let me kind of go back here just to jump the gun. If I double click on this and I highlight what I want to freeze. So let's, for instance, assume that I hadn't froze it yet. So it just says G4. If I highlight that cell reference and then I hold, if I have a PC, hit my F4 button, on some of your laptops, you might have a function key or an FN key. You might have to hold FN and hit F4 because your F4 key has multiple uses. But notice when I do that, it throws those dollar signs automatically up there for me. So F4 or FN F4 on a PC. And if you're on a Mac, it's way different. It's Command T throws those dollar signs in there for you. Okay? So once again, we started out with just G4 and we wanted to freeze that reference. We highlight the reference we want to freeze. We hold our FN key and hit F4, or you just hit F4. Or if you're on a Mac, you hold Command T. Okay. I don't know how they chose that, but that's what they chose, right? Any questions or any issues with that? Like I said, you can do it manually too. You can type it in. But as we go through some examples where we're gonna have multiple things we want to freeze, sometimes this saves us a lot of time, like going through and adding in all these dollar signs. Okay. So now when I copy these down, we're getting the minimum and maximum of every bin, but we really only had to type it in one time. I typed it in, did it in steps to show you, but really we could have copied these down, and as long as we had that one cell reference frozen, everything updates to get the correct minimum maximum values for every single bin. Okay. And it's nice because if we ever go back and change the original data, the minimum and maximum values change, the optimal bin length would change, all these numbers would change. Now the issue is, I'll kind of show you. Let's say I go up here, I don't know, and I want to change, I don't know, I add some more data in, I'll just make up a value. And now the new minimum is, I don't know, 100, right? So if I've used all my cell references and these built-in functions, it'll update all my values. The only problem is my labels, right? I have to type those in, but it at least updates kind of those values if I've used cell references along the way. I'm going to undo that and use the actual minimum value. But that's just kind of showing you that it would automatically update everything. Save us a lot of time, right? All right. Any other questions before we move on to this? So now the next thing I'm going to show you is how we use this Countifs formula. So it's tricky. This is like probably pretty difficult, or at least compared to what I've shown you so far. Okay. So this Countifs formula, right? Really, what do we want to do with these bins? The whole reason we were creating them is because I now want to go through the data and count the number of observations where I see enrollment be between 279 up to, but just below, 12,347.33. So I want to count the number of observations that meet two criteria, being greater than 279 or equal to, right? But also they have to be less than that 12,347.33. So I want to count the observation if it meets those two criteria. So that's what I'm going to use my Countifs formula for. So we'll go into this first one. I'm not going to do this by hand, although with a small data set like this, I probably could. But I'll show you how we could do the exact same thing when I've got, I don't know, 2,400 observations, and it literally would take me the same amount of time, right? So we don't want to do it by hand. We want to use these built-in functions because I don't want to count the frequencies by hand of a data set that's 2,400 large, right? So we'll go back to that Indiana data sheet. It's going to be all screwed up because I was trying to show you stuff. So we'll go back, just start with the equal sign, okay? So the built-in formula we're going to use is called Countifs, all right? So Countifs. We're going to count the number of observations if, and it's ifs because it's if multiple things are true, all right? So we're going to have two criteria. Is it greater than or equal to 279? And is it less than 12,347.33? So I start my parenthesis, and Excel's nice. It kind of lets me know, oh, this function, unlike the minimum and maximum, it takes multiple arguments. So I need to tell it multiple things. So it needs 4 things, right? It needs to know what data it's going to look through, what the first criteria is, and then what data to go look through again, and what the second criteria is. Now, for this example, we're just looking at the same variable, so it'll become a little bit redundant. But the Countifs formula, we'll use it later on this semester. It can be used for multiple variables, and that's why you have to kind of select the range of the variable twice. Okay? Like I said, that might make sense when we get to some later ones, but for now, we'll kind of walk through how we do this. So the first thing it wants is the criteria range. What data is it going through and counting, right? So we're going to go over here. So I've got that Countifs. Notice the formula bar up here always shows me, even if I scroll over, what's in that cell, right, that I was in. So I want to select the entire range of data. So I could use my shortcut, right? Control Shift, hit the down arrow. It's selected that entire range of data for me. So now if I go back to the cell, I can see, or I could have seen up here. Oh, and why is this on Indiana? It shouldn't show this. It shouldn't pop this up. It doesn't matter if it does, you could leave it, but it shouldn't have done that. I think it's because I clicked on something before I did that. So I've got C2 through C51, right? I could have manually typed this in, right? Or use that shortcut to automatically select the entire thing. But this just says, start in cell C2, go to cell C51. That was that enrollment column, right? And I want to count, comma. The second thing I need to tell Excel is, well, what's the first criteria? Well, it needs to be greater than or equal to 279. So I have to put that kind of equality operator, greater than, in parentheses. So I kind of, not a parenthesis, sorry, quotation marks. So I'll start my quotation mark. I want it to be greater than or equal to 279. So we actually just type it in the way you would say it, greater than or equal to, right? So greater than sign, equal to sign. Close my quotation mark. That tells Excel, okay, look, this is the operator, the equality operator I want you to use. Is it greater than or equal to? And then we'll use an and sign. That's just the format. Because the next thing that we're going to tell it is we want it to be greater than or equal to 279. Now I could type in 279 here, but then if this changes, I'd have to go back in and manually type this in. Well, I'm just going to select the cell reference that has that. And I screwed this up because I was clicking around before I showed this to you. So now I'm gonna do something here. I'm gonna just type this in again. So you have to see me do it twice so that it doesn't keep showing Indiana there. So I select the data, and you can see me type this in again, right? What's the first criteria? Is it greater than or equal to? Put that in quotation marks. And sign, just the format Excel needs. Click on that cell reference. Okay. Comma, the third thing I need to tell it is, okay, you went through the data, you checked to see if this first criteria was met. I need you to go back through it again and check to see if a second criteria is true. So you already checked, is it greater than or equal to 279? Well, now I only want to count it if it's also less than the maximum of that bin, less than that 12,347. So instead of selecting the data again, especially for larger data sets, because even if I use the shortcut, I got to scroll back up to see what I'm doing. I already have what that cell reference is. I'm just going to type it out. So C2 through C51, all right? Go back through that same variable, but now we only want to count it if it's less than, right? Put that in quotation marks, use the and sign, and now we only want to count it if it's less than the maximum value of that bin, okay? So a little redundant, we've got to select the range of the data twice. But that's basically the way that Countifs works is look through this data, count the number of observations that meet the first criteria, go back through the data, and now only count it if the second criteria is true as well. Okay. Any questions? So if I hit enter,
You don't have to.
I get 43. If I hit enter, it automatically closes it. You can close it yourself, but you still have to hit enter. So I just, if I get to the end, I just hit enter because it does it for me. It's a good question though. Any other questions on that? Are we having any issues? Okay. So I could do this for the next 5 bins, But the way I have it set up, I can save myself a lot of time. Because when I copy this down, instead of using G7 and H7, well, for the next bin, I want to count it if it's greater than or equal to 12,347 or less than, and less than 24,400. So basically, I want G7 and H7 for the next bin to become G8 and H8. So that's great, because when I copy it down one, it automatically updates those cell references. Problem is, what will also get updated? The cell references for where the data's at. Well, the data's not moving, right? So I don't want that to change at all. You'll kind of see if I hit enter here, if I were just to copy this down, I'm getting all zeros here. Well, that doesn't make any sense. I know the maximum value should at the very least be in the highest bin. Well, what's going on? If I go all the way down here, oops, sorry. Notice it did update the G12 and H12, right? Updated those correctly, but it also updated the range of the data. I'm now missing the first 5 observations or whatever, right? So I've got to go back, hit enter to get out of the cell, go up to this first one. I want to be on one line so you can see it clearly. So I want G7 and H7, the minimum and maximum values of the bins to update, but I don't want the range of the data to. So I'm going to highlight this. I'm going to hit F4 or FNF4 or Command T on a Mac. And I'm going to freeze those 2 places where I was telling it the range of the data to look through. Okay. Once again, I just highlighted that. I had to do them separately because they were kind of disjoint, but I highlight them. I hold FN F4 or just hit F4 on my PC if I don't have a function key, or on a Mac, Command T. Okay. Are you having any issues with that? Any questions? Yes, we're just afraid to ask. Okay. Yeah. So if we've done this correctly, now when I copy this down, remember, left click when you use that big black plus sign, copy that down. Looks like I still have an issue here, right? So why am I getting only zeros here? Well, maybe my bins were kind of screwed up, but notice on this very last category, what's different than the categories before it? So on all these, there was no equality on the maximum of the bin. But on this last one, to be exhaustive, I need to make sure I'm counting the highest value. So I need to go in here, and now it's going to be greater than or equal to 60,000 or less than or equal to. So you have to pay attention to those labels or what you're kind of told, like making sure that's exhaustive. I now just need to make sure I add an equal sign in for this very last bin, right? To make sure I'm capturing that maximum value. Now I do count that maximum value. But these 2 categories still have 0. And that's, you know, if we look at the data, there wasn't anything in between 36,000 and 60,000. So those should be 0. And kind of the next thing I would show you on Monday is, well, sometimes using the optimal bin length produces like a really uninteresting frequency distribution. Yeah.
What if, like, could you just put the less than equal to on all of them? Because I did it on accident and then all.
So you could here and it would work out. But why would it work out in this situation? Because the cutoffs were decimals, enrollment is only ever in an integer, right? You can't have 0.3 of a student. So it worked out here. We'll see in this example that we'll go through Monday, that if I don't have my equalities right, I actually will get my frequencies screwed up. So you need to be really careful that whatever you're told, right, or whatever your labels are, that you're following that when you're putting the equalities in. Yep. So I'm going to save this, and we will start working on this next class. But you can kind of notice here, just before we get out, just real quick, if I select my labels, hold Control or Command on the Mac, select my frequencies. Now I just go to insert this bar graph. Now I've got my frequency distribution. I'll walk through and show you how, you know, sometimes we have to use our brain, change the lengths that we want a little bit to look a little bit prettier. And then I'll kind of also show you some cumulative frequency stuff, and we'll kind of finish out this example, and then I'll assign that first Excel homework after class on Monday. That would be a histogram, right? With the continuous data, force into these bins, and then visually display the frequencies. Did you have a question? Yeah, I would go ahead and save it so you can pick up where you left off when we start class on Monday. All right, there's no more questions. I'll see you guys Monday. Have a fun, safe weekend. Hopefully your first week wasn't too bad.